Today we will talk about views in Monet database. I will first create one sample table, and this table will have two columns, one of chart data type and the other one of integer data type. I will then insert some data inside of this table, and then we can read from our table to see what we got. And this would be our table. And then I will jump to this web page to talk about views. So views are actually saved select queries. We first create a query, we give it a name, and then we save them. And then after we can call that query whenever we want. We can use that view as a table. So in any place where we can use a table, now we can use that view. So it is just our saved query. I will now show you advantages and disadvantages of views. First, they help us to reuse logic, so this will improve consistency. They can make our logic modular. Then, by using views, we can control what users can see or cannot see, and we can also place our views between tables and application. So if something is changed in tables, then we just have to modify our views. We don't have to change anything in application. So by modifying our views, our application and our database will still be compatible. Limitation of views are that first, if we change something in base tables, then we have to change something in our views, otherwise they will fail. And also if we create really complex structures where we have one view that is calling other view that is calling third view and so on, that such structures will be really complex and will be really hard to maintain. I will now show you one view. So for creation of a view, we have to use create view statement. We will provide a name of our view. So we can provide first the name of a schema and then the name of a view. Then we can provide aliases for the columns that will be a result of this select query. At the end, we can use with check option clause, but this clause has no effect in Monet, so we don't have to use it. It will not affect our result in any way. I will now run this, and now our view is created. And like I said, we can read from our view just like from any table. So if I apply select star from view 1, I will get the result that is actually the result of this select query, because this select query is now part of our view. If we want to change something in our query, then we have to use a really similar statement, which is called create or replace. I will paste one example here. So just instead of create view, we will now use create or replace a view. Everything else is similar. This time I have made some changes. I first changed the order of the columns in the select query, and I also changed the alias. So I will run this, and now our view is changed, and we will now see those changes if we read from our view. So I will paste here select star from view 1, and we will get the result that is different than this result before. We have different order of columns and the names of columns are different. I will now clean my screen. Like any relational database, Monet is saving its metadata into system tables. But those system tables differ between different database servers. And in order to promote standards, SQL committee introduced standardized views, which are called information schemas. And I will give you now an example of such view. So this is such view. We will read from it, and this view will pull data from system tables, and then it will present that data in standardized way. So what is interesting here is that this query will work in Monet database, but it will also work in many other relational databases, like for example Postgres. Then I will show you one of those information schemas that we are now interested in the most. And this is that information schema. Here we can see a list of all of our views. So if I run this, I will see data about my view that I have previously created. So this is how we can find a list of our views, and we can see different attributes of our views. I will now clear my screen. It is possible to create one view based on the definition of some other view. I will now create view 2, which is based on this view 1. So if I run this, I will create another view. We can read from that view 2 to see that it differs from the view 1, but it is created based on the view 1. After this, I can now just try to delete view 1, but I will fail. I will fail because now we have this view 2, which is dependent on the view 1. So this deletion will not be allowed. In this case, we can first delete view 2, and only after that we can delete view 1, and this would be possible. But the other possibility is to use a drop view statement with cascade keyword, like this. In this case, we will delete view 1, but we will also delete any other object that is dependent on the view 1. In this case, that would be view 2. So if I run this, this will be successful, and now view is now deleted. If I now try again to delete this view 1, I will get an error because we cannot delete something that it doesn't exist. But we can avoid this error message if we add if exists subclause like this. If we add if exists, in this case we will not get an error. We will always get operation successful message. But if our view exists, then it will be deleted. And if it doesn't exist, then we will just get this message, nothing will happen, but we will not get an error message. I will now clear my screen. We will now talk about indexes. I will jump back to this web page, and here we can see something that is usually at the end of a book. We see an index. Index is a list of terms, and beside each term we have a list of pages on which we can read about that term. This list is alphabetically ordered, so it is really easy to find some term, and then based on that we can find pages where there is a content about that term. And the similar thing do exist in tables in databases. For example, here we have one table, but beside it we also have an index. Index has a list of all of unique products, and beside each product we can see on what rows we can find those products. And it is much easier to search to this index because it has only 2 rows than to this table because it has 5 rows. So existence of an index will speed up reading of this table, but when we do some insert, update or delete, then we have to recalculate our index to recreate it, and that will slow down our database. But we usually spend much more time reading data than writing it, so it is a good thing to have an index. And how to create an index in MonetDB? Well, for that we don't have to worry because Monet will create all of the necessary indexes for us automatically. But it is still possible to create an index manually, and for that we can use create index statement. This statement will create index with the name int1 on this table and column, and the name of an index has to be unique inside of the schema to which this table belongs. So if I run this, I will get operation successful. But Monet has a discretion to ignore this command. Monet will decide on which column it will create an index, so Monet can ignore this command and it can consider it only as advice. It is also possible to create an index on several columns, and for that we have this statement. This statement is using unique keyword, but this keyword is useless in Monet, so we should avoid it. And we can see here that we are creating an index on 2 columns. So we go back here to this web page, we will see that for each unique combination of values in these 2 columns, we will get an item inside of our index. So now it is easy to find each of these unique combinations. And that is why we have index on several columns. So if I run this, we will actually get an error because I have used the same name for this index as for this previous index, and that is forbidden inside of the same schema. Next, we will again go to this web page, and we will see here that it is possible to create several indexes on one table, and it is even possible to create several indexes on one column. But we should avoid that because that doesn't have sense. I will now go back to this terminal, and then I will show you how to get a list of all of the indexes, and for that we have to read from this system table. Inside of this system table we can find all of our indexes, and here is the newly created index. We can also delete that index by using drop index statement, and then we will provide a name of an index. So if we run this, our index is deleted. I will now clean my screen. Monet supports some special indexes, but those indexes are experimental. And because they are experimental, we should avoid them. And the first one is ordered index. Here we can see an example of an ordered index. Ordered index is special because items inside of index are always sorted. And because of that, it is much easier to find some specific item, to filter items by ranges, or to sort data in the data table. There are some limitations on this ordered index. Those limitations are, first, that we can only create this index on one column, and the second one is that after update, delete, or insert, this index will become inactive. But the problem is that these limitations are only enforced by Monet documentation. So Monet itself will not enforce these limitations, and probably because these indexes are experimental. For example, if I go here to terminal, I can create an ordered index. You can see that here. I'm creating an ordered index, but I'm creating it on two columns. So if I run this, this will be successful. If I read from my system table, I will see that I really have successfully created a new index. So because this index is experimental, I'm not really sure when this index is active, it is not active, that is unclear. So the best bet is to follow these steps. First, make your table read-only. You can make your table read-only with this statement here. So I will run this statement. Now my table is read-only. After this, we should create this ordered index, but by only using one column. And after that, we shouldn't make any other changes to our table. And I think that if you follow these steps, that then your index will be active. So idea of this ordered index is to create it only ad hoc on the read-only tables, because creation of this index is really expensive. So that is an idea. I will now make my table read-write again. I will change it back. And I will also drop this index in one, and then I will clean my screen. Next, we will talk about imprints index. Imprints index is similar to ordered index. It is also an experimental index, and it also has some limitations. And again, those limitations are just theoretical. The first one is that this index should be created only on numerical and 3 columns. Then after any update, delete, or insert, this index will become inactive, and we should always create this index on only one column. And just like for ordered index, we will never be 100% sure whether this index is active or not, so we should follow the same 3 steps as for ordered index. We should first make our table read-only, then we should create our imprints index by using only one column, and after that we shouldn't change anything else about our table. If we are using this index on numerical column, we will do it like this. We will first divide our numerical column into segments. And for each segment, we will create some metadata. For example, we can calculate maximum value, minimum value, and so on. And then if someone tries to apply, for example, a filter where he is looking for values that are bigger than 30, we will immediately know that we shouldn't look for those values in this first segment, because here the maximum value is 25, which is less than 30. Now those values are also not in this last segment, so they have to be in these middle 2 segments. I will now show you how you can create this imprints index on numerical column. So this operation is successful, and immediately after this I will delete this index, and then I will clean my screen. The purpose of the imprint index on the string column is to allow us to use fast but imprecise algorithm to pre-filter our data. And then on that reduced set of data, we can apply normal algorithm that will find precisely the rows that we need. I will now try to create one imprint index on letter column, but I will fail. In this case, Monet will enforce requirement that our table should be read-only. So I will make our table read-only by using alter table statement. And now that our table is read-only, again I will try to create this index, but I will fail again. And this time limitation is that our table should have more than 5,000 rows. So because this table is read-only, I again have to make first my table read-write, and only after that I will insert those 5,000 rows. And for that I will use this statement here. This statement is using system table, systables, as a dummy table. So we're using this cross join here to create a dummy table with 5,000 rows, and then we will use this select statement to insert these two values 5,000 times into our table. So if we run this, we will see that we have 5,000 rows affected, so that means that we successfully insert those rows into our table. And then again we have that other requirement that our table should be read-only. So again I will make it read-only, and only now I will be able to create my imprints index. So now we will have an index on our table, and at the end we can delete our index. So this index is also deleted with drop index statement. So I will delete this.